Hi student, how are you doing today? Today we're going to discuss PHY260 chapter 4 about sound. In this chapter, we divide into 4 subtopics. For part 1 is about sound wave. These are the content that we're going to discuss in this chapter, which is sound wave, intensity of sound, interference of sound wave, and Doppler effect. (4.1) Sound wave. Sound is something that you can hear, something that makes noise, such as people talking, clapping hands, sirens, from musical instruments, and etc. But do you know what causes sound? What causes sound? Or how do you produce sound? Sound can be produced by vibration, such as clapping your hand. When you clap, there is a vibration of air molecules surrounding the hand, and the sound will travel to our ears and it will vibrate our eardrums. That's how we're able to hear sound. Some information that you need to know about sound wave. Sound wave come from vibrating sources as we discussed earlier. Second, sound can travel through medium. Third, sound wave are longitudinal wave. Fourth, sound wave is a form of energy. Do you know that sound can travel in vacuum? Unlike light has no problem travel in vacuum, but sound need medium to travel to different point. The speed of sound are differ when it passes through different medium. The slowest will be in medium such as gases, and the sound will move fast in solid. Refer to table 16.1. The speed of sound also depends on the temperature. As in previous slide, sound wave is longitudinal wave. What is the difference between transverse and longitudinal wave? Transverse wave is when the particle vibration at the right angles to the direction of wave travel. Right angle means perpendicular, or from the picture, the particles is moving up and down while the wave is moving to the right. Example of transverse wave is EM wave, light wave, microwave, etc. While for longitudinal wave, which is how sound travels, the vibration of particles are parallel to the direction of wave travel. Example, sound wave and ultrasound wave. Next, production of sound wave. For example, we have tuning forks. When we hit the tuning forks, it will vibrate. As it vibrates, it will disturb the air molecules. There are two processes involved, compression and rarefaction. Compression is a region in longitudinal wave where the particles are closest together. Rarefaction is a region in a longitudinal wave where the particles are furthest apart. Details on how sound produced and travel by longitudinal wave. When the tuning forks begin to vibrate back and forth, it will produce disturbance of surrounding air molecules. The high pressure regions are known as compressions and the low pressure regions are known as rarefaction. As the tines continue to vibrate, an alternating pattern of high and low pressure regions are created. From the picture given, the air molecule will compress and expand. The compression and expansion of molecules we can draw graph. The graph represents the air molecules. The compression of the molecules referring to the maximum peak of the graph. Besides that, longitudinal waves are often called pressure wave. The displacement is 90 degrees out of phase with the pressure. Between two compressions is the wavelength of the graph.